Hi everyone. So we're going to see the class with the quote of Dr. Kalam, where he says, I'll just read out. He says the best brains of the nation be found in the last benches of the classroom. So what does he mean by last benches? Does he mean that who's sitting on the last bench literally? Let's say you have 10 rows in your classroom. Whoever sits in the 10th row is the last bench. That's what it mean? No. He doesn't mean that. He actually means that you could have 60 people in the class, for example, right? Your class has a 60 students. You could have arrears, you could have failed, or you could have taken the last rank, 60th rank. So he could be a best brain, right? That's what he says. So it doesn't matter your first rank or last rank in the class. Yeah, it matters though, but in terms of industry, it doesn't matter. Once you get to industry, to get into the industry, the marks matter. Once you get into industry, it doesn't matter where you graduate from, what rank you took, your master's, bachelor's, you're from MIT, Stanford, or a Cambridge University, or a Vishnu Institute of Technology, or a Chennai University of Technology, whatever, no, or IIT, or a BITS Pilani, it doesn't matter. Your brain, what is the brain? Is your skills, your knowledge. We already spoke about the skills and knowledge. So those are more important, right? The skills and knowledge mean a lot. We have seen what is the knowledge, what is the skill, and we have seen what is the difference between training and teaching and mentoring and coaching. We will keep doing that as we proceed forward, right? So, so he says that so you could don't worry about your rank. Don't, your degree is just a piece of paper, as Dr. Kalam has earlier said. We discussed about that quote. So you should be skilled enough. Don't worry if you have arrears. If you take example, some of my classmates who have failed, they've had arrears, they are top leaders in the industry today. I cannot quote the names, but they are one of the top CEOs or a top HR, or they are very successful engineers today. So don't lose heart if you scored 50 marks or 60 marks or you had arrears. Put your best effort forward, and you could do better, right? So with that introduction, let's go to the what is the life cycle of the product. So we have seen so far what is the we have seen so far what are the planning phase and what are the one second. So we have seen so far what is the strategy phase and planning phase. Now we shall see what is the execution phase. Right? So execution phase contains the actual execution of the project. It's going to take quite a long time. So this actually the committee two has approved. So the PH2 we said, right? We spoke about in the last video. Your, where you have all the approval, manager approval to start the execution of the project. Now we are actually doing the execution. So what component will go in software? What component will go in hardware? What will be the board? We have seen what is the product, electronic product. So we have seen it's a combination of the hardware board or PCB, and it's a combination of a software and hardware. So that's what is a product or a system, right? We are talking about the system, basically, right? So it's basically what is saying we are saying is so we are do the architecture of the product. That's what we are doing, right? So we'll do the architecture. So there's a system architecture team. They work. System architecture works together with hardware and software teams. So on the board teams. So that's the system architecture team. That's the highest level of architecture. So they keep the entire system and spec and everything in mind. They come to the system architecture. It says how many what actually go in software, what will go in hardware. One quick example. How do you determine some functionality has to go to hardware? Can some of you think about it for a minute? You can pause the video. Okay, let's resume. Right? So it's basically any activity has to be done in real time, on the fly, right? So that can be done in a hardware. Anything is not time consuming, which doesn't need a lot of computing power, it can be put in software. So typically control paths, everything will go into software and hardcore data path could come to hardware, but it's combination of both also. So software is always reconfigured. You can have a patch, you can release the software. So you have a flexibility in software. But in hardware, it is not so. Once you put and tape out a chip, but done for it. But if it is FPGA, you can reprogram. But FPGA versus ASIC, we'll see that. FPGA versus SOC, we'll see in a few slides or next class, next video, we'll talk about that, right? So first step of the execution phase is the architecture phase, and you have to close the architecture. You have to finalize what goes in the software, what goes in the hardware, that is a chip, and what goes in the board. right? The overall interfaces, all those things are finalized, right? So we'll see if we can find an example for architecture spec. I'll try and add as a reference in the classroom. Please do remind me, right? And then the microarchitecture. So now we are going to talk about more of the hardware. We'll take less of the software because most of the people here are the electronics and electrical engineers, right? So let's talk about more about the hardware. So we take an architecture diagram. I'll show you some of the architecture diagrams as an example in a few slides. Please wait. So we're going to take one block at a time. So we do something called a top-down design. What is a top-down design? You are going to construct a house. Right? What do you do if you want to construct a house? Do you construct a kitchen first? You construct your restroom first? You construct a master bedroom first? Then you construct a living room? Then the balcony or a car parking? That's how you decide? No. First, you find out what is the area available to you. So 2,400 SFT typically, right? We call one ground or 200, 2,400 SFT. It can be any dimensions. So that's equal to your budget. What we spoke in the previous slide. We spoke about the budgets, right? Budget approval. So that's your budget. That's the space what you have. 2,400 SFT, right? You take the 2,400 SFT, and so then you have to divide. You have to do something called when you do a building a house. What do you first do? You do something called a layout. You do something called a blueprint. Right? What you do? This is a you based on Vastu Shastra. You all believe in Vastu, right? Or we are all Indians. So we use a Vastu complaint. That's what we ask when you buy any properties. So your kitchen has to become in southeast corner. I'm just assuming. I may be wrong. Your living room has to be. Your master bedroom has to come in west southwest corner. Let me assume. Right? I could be wrong. I'm not a Vastu expert. I'm just assuming. Right? So your living room has to be somewhere. Right? Your restrooms has to be somewhere. The specific rules which must be there. Right? So you have to put your things in certain way, right? You cannot just haphazardly put. And how much space you want for your living room? How much big is a bedroom you want? How much big kitchen you want? Open kitchen, closed kitchen. So that's your specification. Based on that, you arrange your layout, right? Similarly, we do a partition of your specification design. You make architecture and then you divide into block diagram. Your block diagram will be something like this. I'll show you. I think we'll worry about the block diagram later, right? So it's too detailed. I'll show you examples of a block diagram. Don't worry, right? Or you can search in the Google or for a block diagram, right? So the block diagram will be there, and so there'll be a high level block diagram. We do everything top down. So the top level block diagram it will have typically it will have a CPU, right? If you take let's take a mobile phone, we all know, right? You'll have a CPU, you have a DSP processor to process the voice algorithms or data processing algorithms. CPU will run the operating system and other applications. You will have a memory, flash memory or a EEPROM memory. So if you don't know, yeah, we'll talk about that in your design classes. We'll have memory. I'm sure you all know what is memory. Primary memory, secondary memory, tertiary memory you would have read in your college, right? So your tertiary memory is your hard disk. Primary memory is your SRAM. Secondary memory would be your flash or a ROM, whatever. Right? Depends on how you classify. L1, L2, and L3 memory. We'll talk about when you do the processor architecture. Level 1, level 2, and level 3 memories. Right? So you have memories, you have peripherals, you have bus interface to connect all the components, and you have some logic like DMA interface and you have SPI, I2C. Some of you want to know some of the peripherals. We'll talk about that very soon. I'll create videos for that. Right? So you have to divide a block diagram, for example. Right? You have a CPU and you have a modem, Wi-Fi modem or a 4G or 5G modem, and you have Bluetooth. You have IR, right? What are power management, power amplifiers, phase lock loops, ADC, DAC, right? Camera interface, display interface, right? And RF antenna. There are so many components will be there in a system, which we shall see in a separate video, right? So that's called microarchitecture. So first phase is to do the microarchitecture. Based on architecture, you do microarchitecture. First, what I described is architecture. That output of this particular phase goes to microarchitecture. Now we are going to focus primarily on the design side, on the hardware side. So software side, if there is interest, we'll talk about it. And I do have slides on that. Based on interest, we can talk about it. It's good to have understanding of how the software, the driver, we call it the hardware abstraction layer. I'll show you a better diagram. Let me talk offline. Let me prepare a slide and I'll show you how the hardware and software interacts. We call them as device drivers. You would have seen in your Microsoft like an operating system, right? You have something called device driver, right? So you have to install the proper device. Otherwise, your audio or a video card may not work properly. Your USB may not work properly. So that's called a hardware abstraction layer, right? That's a first software which talks first level of software which talks to the hardware. The microarchitecture, we take a overall diagram. Let's say we have a CPU subsystem. We take the CPU subsystem and break that into small things, small blocks. It has how many core CPU? 8 core or 4 core CPU. Does it have a L2 cache? And what are the peripherals does it have? What does it have a watchdog timer? We spoke about watchdog timer, I suppose, right? So what are the peripherals does it have? Right? Does it have a any power collapse logic? Because your CPU may be sleeping, save the power. Right? We'll discuss about the details. Right? We would have, I think you would have written the spec. Whoever you came up with the laptop spec, you know what are the various components, block diagram. So after you finish this classes, next month you go back and revise your requirement specification to do a better block diagram. You should be able to do for your design. Right? So that's the block diagram. I'll show you a case study. The next videos we'll see how a block diagram looks like and how a microarchitecture is done. Right? So we'll take one block and divide. It's like a divide and conquer. If you take a sports, for example, take a football. Let's take a cricket for example. Right? The first team is plays. It scores some 250 runs in a 20-over match. The second team has a target, so it has to meet the target. Right? So it has to. If they get the target, if it is less than 250 runs, you will fail. You are going to lose the match. If you get more than that in the required overs, you will win the match. Right? So similarly, you have every block has a functionality and it has to be done in certain time frame. Right? So you based on the functionality, you divide the block into various sub blocks, and each block gets it's divide and conquer. Right? So that's how you do. Right? You have to plan. For example, you are planning for a holiday. You will say, I want to go to Goa. Okay, so that's your goal. How do you go to Goa? Again, use the WH questions. You go by bus, you go by train, you go by flight, or you can by rocket. You go by private jet, we can avoid that. Many of them go by a bus or a train. Right? We are from a lower middle class family. Right? That's what we communicate. Right? Then you have to what are the dates? Again, you see how I am using the WH question. What are the dates? When do you want to go to Goa? And you have to check the hotel is available or not. And then you have to see the tickets are available or not. Right? Bus tickets or train tickets. Then you make what are the things you have to take along with you, right? You take your how many clothes you will take, you're good any sports accessories you want to take, whether you want to take your laptop computer or just going on a vacation, then you don't need a laptop computer. Just go with your phone. So you plan the things accordingly. What do you need for your travel? What do you need for a stay? Whom you are going to meet there? How you are going to what places you are going to visit in Goa? So you are going to do everything top down, right? You don't start from the bottom. You don't say I want to see 10% Goa. Then you don't. Then I want to see book my ticket, then book my hotel. Then what is Goa? Where is Goa existing in India? Or is it in Pakistan or Sri Lanka? Don't do that, right? You start from the top to bottom. You do the planning. Similarly, that's what's called top-down design. So I'll show you an actual example of what top-down design. Don't worry if you don't understand. So once you have a microarchitecture, we do something called a Verilog. Use a system Verilog. Use a Verilog or VSDL. There are various coding techniques. They're just it's called coding. I hate people when they say programming. Right? It is not a programming. We are all hardware engineers. We are all design engineers or verification engineers or implementation engineers. Right? So RTL means for register transfer level or register transfer logic. That's what RTL means. Okay? So that's basically your actual design. So you make your actual design, you code the design. So you don't please don't call it as a programming. I'll get furious. Okay. So don't take me wrong. It's called design, RTL design. It's called RTL coding. It is not RTL programming. Please understand that. So once you have RTL design, that's like behavioral design. So you write that code, right? Once you write that, you can always simulate. So the simulation is important. We'll see that in detail. Don't worry, have flow charts. We'll explain all this in detail in a separate class, separate video, 1 hour video or half-an-hour videos we'll make. Right? So we do RTL design, then we do verification in parallel. So we have write a test bench, they call it test bench. So I'll give you an example. You may not understand what is a test bench, we'll see an example. Test bench is a piece of code, it's going to test your design is working correctly or not. Let's say you cook a food. How do you know it's cooking food? The food has been cooked well. Either you have to taste it yourself or you find a lab rat. You ask one of your brothers, sisters, or a parent or a friend to come and taste whatever food you have cooked. So typically I call them lab rat, right? So that's what my kids say, right? So I'll be the lab rat if my kids cook food, or if you cook food, my kids will be the lab rat, right? So test bench has to be fully automated. It has to be fully self-checking. You don't want to look at the waveforms and decide the test design is passing or failing. It's a high-level concept. You understand this one line, please you take your notes, but we'll see that in detail later on, right? So once you then you have to write test cases. Again, we'll talk about them in detail. You have test bench, test cases, verification planning. There's a separate topic by itself. It's a huge, it'll be a 3 months course. We will do that separately. Once you understand the design, we'll go to verification. Right? Once you do RTL design, you do some process called synthesis. Synthesis is a process, again I repeat slowly, synthesis is a process where you convert your RTL code into a gate level design. What is a gate? Your combinational circuits, sequential circuits, memories and things like that, right? This RTL design is basically digital logic, right? Analog, you cannot write RTL, you cannot synthesize. There's a separate for analog design. We are talking about digital design in general now, right? You write RTL and use a tool called synthesis to map, and you have to use what are the constraints, what are the technology library, use that and convert your RTL design into a gate level netlist, right? And then you get a clean collateral release. What is clean collateral release? We'll see that separately. When you talk about synthesis, I'll show you what is a clean collateral release. Collateral is something what you have to give to the other person, right? Let's say you're two people, you are there, you're working together, preparing for exam together, you're studying together. There are 5 chapters for your end semester exam. You study 2 chapters, other person study 3 chapters, right? You take notes, then you teach the other person, and other person teaches you, right? That's how I prepare, right? I tell my friend to prepare for 3 chapters, I prepare 2 chapters. Then we can divide the work. Then you know what you have to prepare, what he has to prepare, and you expect him to do chapter 3, 4, and 5. I do chapter 1 and 2, and I prepare notes and some raw notes or slides, whatever it is. I'll check Google, YouTube, I'll prepare the notes, and other friend also prepares. Then we exchange information. Collateral is what information you pass to the other person. You send the notes of the first and second module to the other person. Other friend, you sends the notes for the module 3, 4, 5 to back to you. So that's a handshake which is happening, right? That's a collateral. So you should define what is the quality of the collateral. Let's say your friend is not serious, he is giving some junk thing to you, and you do a good work. I'm saying it could so happen because of various personal restrictions, or it could be personality disorder or whatever. No, I'm sure you would have seen a movie called Tare Zameen Par. There are a lot of movies are there, which you can go and check. What is the autism? What is the disorder? Right? All of us go through that phase, depression. We all get stress, right? So we'll talk about it separately. How do we handle stress? How do we handle depression, right? So we will, if you are interested, we'll talk about it separately, right? So the collateral is important. What quality you are going to give to the other person? What time you are going to commit? What are the items you are going to deliver? I'm going to give a PPT. I'm going to give a raw notes or handwritten notes or diagrams or tables, flowcharts. No, I don't know. All those things has to be defined before you start the divide the work into a agreement, right? So that has to be, that's called a collateral, right? For example, you take a loan from the bank to buy a property or for your agricultural farm. You have to send what is you have to give hypothecate your land documents, and you have to give some collaterals where somebody has to come and sign. Your friend or your some known person has to come. I take responsibility. If this guy doesn't pay, I'll pay. Right? Typically, bank has some collateral, or you're taking a loan from the bank. You have to keep your mortgage. You have to give your house on a as a collateral. You have to give it to them and take a loan from them temporarily, right? Or any material, gold loan, you do like that. Right? You put your gold as a collateral. You take a money, right? So that's a typical example of a collateral. Right? So then, so this we spoke about briefly. We will talk about in detail. Don't worry about verification. The first process focus on the design, but we'll understand verification in more detail. Verification, as I tell, I repeat again. Verification is a process which use it to verify a piece of design automatically in a self-checking manner. Right? Initially, it will be doing waveform check, but the test bench design also a very comprehensive process. It has to be very automatic, self-checking, and there are a lot of UVM and system Verilog, and in these days we have something called Coco TB and Blue Spec. There's a lot of languages, a lot of methodologies, right? So we'll see that in great detail as we move forward, right? In the next semester or this semester, we'll see how fast we pick up, right? We'll see that, right? Then we have something called design for test. So it's extremely important concept. The beginners doesn't understand that. So let's you fabricate a chip, right? So how do you know the chip is working fine? So it's extremely important concept, right? So how do you know the chip is working fine? You can run a functionality. For example, you have a DMA, you can run a DMA, or if you have a SPA, you can test the SPA block, or if you have UART, you can test the UART block, or if you have memory, you can test the memory as such. And those are called functional tests. That's what this person is doing. But how about the manufacturing defects? Right, which is not you, it's not in your hand. You send the chip to a foundry. We spoke what is a foundry, I believe, right? It's, fabs are coming in Gujarat, Vedanta, Foxconn, and there are Indian companies also going to come. For example, there are I cannot announce it in public. There are a lot of packaging companies, fabricate who can fabricate the wafers and do a testing. All those things are going to come, right? So test when you have fabricate, you get a wafer. You can do a test at the wafer level. can test as a die level. When you package it, they can test as a package level, right? Basically, focus on the manufacturing defects, what you call structured faults. So when you manufacture a chip, the die, right? There's a process, right? So manufacturing process. There's something called etching, lithography. There are various techniques. We'll talk about that in detail after the CMOS. Once you understand the CMOS class, when Bharat talks about the CMOS, we'll talk about basics of fabrication, how a CMOS inverter is fabricated. So we'll go through the basic steps for a 180 nanometer technology. We'll walk through that, right? So we should, so if there is any contact, which undesired contact which happens, one particular net or a signal will be stuck to one unintentionally. You are not that particular signal should not be touched to VDT or a 5 volts or 3.3 volt, whatever your power supply, right? It is supposed to work as a signal because of it has had a contact with the power signal unintentionally because of fabrication issue. If you know what is soldering in your PCB, you put a solder iron, you make a connection to your power track unintentionally, right? So that kind of defect can happen in PCBs and it can happen in the manufacturing also, right? So that's called design for test. You have to catch those kind of defects. There are a lot of defects are there, become memory defects and sequential logic defects, combination logic defects. And you have to generate test vectors for that. And you have to make your RTL design test friendly. You have to insert lots of logic, combination logic and sequential logic in your design to make your design testable, right? So you have to add additional logic, you have to introduce additional area to do the particular design for test. So for to test the scan and memory base. So we'll talk about that in subsequent videos, subsequent later. That's a huge topic by itself. There's a 4-month course which I'll run in my academic institute in the next month. I'm going to start that, and I'm planning to put all the videos in public. You can watch if you have some background knowledge. If you're a prerequisite, if you can know, you can watch the knowledge, and whatever we do now as a team, or like-minded people, we will put everything in the public domain. That's what we decided. So that's why we do form of videos. So other people can also generally you can highly circulate this video. Feel free to circulate the videos to your friends, right? And in the physical design, there's a bunch of process, right? It's called floor plan, power plan. So I'll probably going to pause the video because it become very huge. So in the next video, we'll talk about floor plan, power plan. That's what it's called physical design, right? How it's called implementation based on the technology, what you have used, 90 nanometer, 190 nanometer, 180 nanometer, 45 nanometer, 20 nanometer, or today we are working on a 4 nanometer. Right? That's what TSMC is working on today. Big companies are working on a 4 nanometer, right? So based on that tells you what is the your channel length of a transistor. I think you will very soon we will hear from Bharat. There's something called a drain, there's something called a source. The distance between the drain and source is called a channel length. So that is called a floor plan, right? So we do a floor plan based on what blocks has to be placed where. Again, it's like your house construction, what you told the beginning in the architecture phase, right? So you have a CPU block, where do you place it? You have a memory block, where do you place it? It's like basically similar to your blueprint of a house or a layout of a house. That's called a floor plan. And power plan also you have various power supplies. You have at least 5 volts and ground, right? Because you have other voltages also. We have multi voltages. This you have 3.3 volt. But IOs input output will work in different voltages. Let's say 1.8 volts. Let's say right. Or different IOs will work in different specs. Right? Your memory may work in different voltage, and your UART may work in different voltages. Your digital GPU IOs may work in different voltages. That's quite possible. So we have to create a power island. We have something called power plan. And these are very high level concept. Please take notes. And I would like to review the notes how you understand, or you can rewind the video and see. Right? So video is getting big, so I'll kind of pause it now, and we can introspect, and we can talk about that in the subsequent classes. We'll continue about more details about physical design in the subsequent videos. But till then, see you everyone. Have a nice time. Bye bye.